So it says the graph of a continuous function g, the derivative of f, is shown above. The function g is a piecewise, they're saying these are all straight lines, and then this from here, from 3 on, becomes this function. If f of 1 equals 3, what is the value of f of negative 5? I did one for you like this on our worksheet, where I go, okay, let's do this. So f of 1 is 3 minus. So I'm going from here, and I want this value. So I know at f of 1 it's 3 minus. Why am I minusing? Because I'm working backwards. Y'all with me? Find this area of this triangle right here. So minus the area of that triangle. Well, it's 1 times 2. Half of 2 is 1. Now, what's the area from 0 to negative 1? Nothing. It's 0. I'm going to find the area of this little triangle here, 1 by 3. Half of 1 by 3 is 3/2, but isn't it below the x-axis? So isn't that area negative 3/2? And I found that little triangle because then I have this square. The square is 3 by 3. That's an area that's negative 9. But since I'm going backwards, emphasize again, I'm going to go minus. So let's go. It's going to be 3 minus 1 plus 3/2 plus 9. That's going to end up giving me an area of 12.5. Okay? That's B, or that's A. B. They simply in B tell me just evaluate the integral of this graph from 1 to 6. Now what you should do is you should go from 1 to 3. You should go the integral from 1 to 3 g of x d of x plus the integral from 3 to 6. And I was given a function. Look up here. I was given what this is. From here to here, it's what? 2 times x minus 4 quantity squared d of x. I'm going to hit pause. Actually, I'm not going to hit pause yet. Look up here. What's the area from 1 to 3? It's a square above the x-axis, so it's a 2 by 2. So what's this area right here, guys? 4. Plus, take the antiderivative. I'm going to move this 2 right here out in front. So 2, and then look up here. Walk me through this. If I make this u, what is that? U squared. So if I make that u, the derivative of u, so if u is equal to x minus 4, what's d of u? Just d of x, or d of x, right? So what's the antiderivative of u squared? 1/3 u cubed. So 2 times 1/3 x minus 4 cubed from 3 to 6. I can see it in your eyes. You guys are spent. So this is 4 plus this area here ends up being 6. Look, 6 minus 4 is 2. 2 cubes 8. 8/3 times 2, and then I'm going to plug in 3, and I'm going to get a negative. So I'm going to get 8/3 minus negative 1/3, which is 9/3, which is 3, and 2 times 3 is 6. So that entire area is 10. I'm going to erase this. So I'm going to do this. There we go. And I can come back to it if I need to. Okay. C. From -5 to 6, the whole thing. On what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. So you don't need to know jack from A and B to C. Come on, stay with me on this part, please. You guys should all get these points. I'm asking for the increasing and concave up. Again, the graph G is f prime. Okay? If the derivative is positive, that means the original function was increasing. If the derivative is negative, that means the original function was decreasing. So, I'm only looking at this because they want to know both increasing and concave up. So, from 0 to 6, I'm increasing. Agree? How do I find concavity from the derivative? When the derivative is... No. When the derivative is positive is when it tells me increasing. I got to go concavity now. When the derivative is increasing, that's concave up. Because what's the slope from 0 to 1? That slope is what? Positive. The derivative of the derivative is positive. So my increasing concave up would be from 0 to 1 and from 4 to 6. Let's write that down. From 0 to 1 and 4 to 6. And I would say this is my justification. I would write this down. The derivative was greater than 0, which meant increasing, increasing, and the second derivative was also greater than 0, which meant concave up. So because f prime is greater than 0 and increasing. Maybe I should say because f prime was increasing also, to justify getting those points. Okay, we can do D then. We can do D. Where is the x-coordinate where I have a point of inflection of the graph? Where does the derivative go from increasing to decreasing or decreasing to increasing? Flat, increase, flat, increase, flat. Here it is. Decrease to increase. There's a point of inflection at x equals 4. Justify why? Because the derivative went from decreasing to increasing.